Hello, my name is Samuel Pacheco, and I will be presenting on Project 2 for Business Calculus. Apologies if I'm quiet. I can't be too loud right now, and I'm very stuffy, but let's get into it. Suppose I were to describe a collection of data that observed the purchasing consumption trends of governments, persons, and businesses, an index of information used by the Federal Reserve to determine the implementation of specific policy, and by corporations to understand whether to increase the price of a particular good or service. This collection of data is referred to as the producer price indexes and consumer price indexes. These indexes are important to maintain data of consumption in order to analyze and determine statistically proper pricing and can be observed to understand projected inflation. Let's observe some calculations. I am the owner of a bank and I'm calculating the cost of servicing bank customers and servicing loans. I'm interested in figuring out the extra cost of adding one more customer or loan. I will be calculating to find the marginal cost, which is the rate of change of the total cost. My bank analyst has provided me with the cost function. The cost function can be written as C of x equals 6 minus the square root of f of x. That is right now our cost function. We will be starting by finding the prime of the cost function, which will give us the derivative of the right side of our graph, which is a compound function right now. So we will be determining the two portions of that function. The c prime of x is equal to the derivative of 6 minus the square root of the function of x. Okay. Secondly, we will be applying the power rule. And let's start by having the c prime of x equal to n minus 1. So that we have a square root. This will be functioning as our power rule for finding the c prime of x in order to establish the derivative. So 2x1 minus 1. So since we are using a square root function, we'll be using 1 over 2 as sort of a way to determine how to find the derivative of this particular function. So 1 over 2x, 1/2 minus 1 is equal to 1 over 2 times x to the power of negative 1 divided by 2, which is equal to, because it's a negative power, it's a negative power, it's equal to 1 over 2 the square root of x. So the c prime of x is equal to 1/2 to the power of x. Now that we have that, we can apply the chain rule. Pardon me. So now that we have applied the chain rule, we're going to be using, now we're going to be plugging in this guy right here into our c prime of x. And it can be said that finding the derivative of the first portion of our function, which was 6, the derivative of that will equal 0. And since it was 6 minus in the function, our function will inevitably be negative. So the derivative of the 6 is equal to 0. So I'm going to write 0 minus. And then we have our function, which was and we will be multiplying by the function prime of x. So here we go. We have established this 0 minus 1 divided by 2 times the square root of the function of x times function prime of x, which in simple terms is equal to negative function prime over c prime of x is equal to negative function prime of x divided by 2 function of x. Here we are. That is going to be our marginal cost function. Okay, now that we have solved that, let's get on to our second course of action. Okay, and now that we have calculated the marginal cost function, let's move on to reviewing the graph of the consumer price index. So we are given a graph. The graph of the consumer price index is listed right here. So we have our x-axis, which is going to be January of, we're assuming 2022, February, March, and April of 2022. And our y-axis, which is listed as the numbers 5, 6, and 7. The consumer price index is increasing over the period of January to March. Here we go. It is increasing between the periods of January to March. The rate of change of the consumer price index is positive over January to February. And right here, rate of change, January to February, and February to March as well. We can move on to question 3 now, which asks of the shape of the graph. If the annual rate of change of the consumer price index is decreasing, and if the annual rate of change is decreasing, the graph will concave downward. This doesn't necessarily mean the graph isn't increasing with a positive slope, but it could be moving at a slower rate. So let's use, I guess we can reference the same dates now because it's a consumer price index. Let's use January 23. So it's the next year. January 23. February through April. And I guess we can use the same numerals, 5, 6, and 7. And so right now we're asking if the CPI was decreasing. So we're going to graph a decreasing slope right here. So January started at January it started at, let's say, 5. And February it was going to 6. But then we went to March and we were at 6.3. In April we were at 6.5. So see, these are the dots on our CPI. It's going to be referencing January 2023. So although our graph is positive, although we have a positive incline, it doesn't necessarily mean the rate of change will be positive, because technically, since the graph is slowing down, the slope is decreasing. The rate of change is in turn decreasing, and therefore we have a concave downward graph. We are then asked if the annual rate of change was increasing, what would that graph look like? So here I have listed for the producer index, here I have listed a graph. So we can use the same dates because it's a different index. So January 23, Feb, March, and April. That will now be our graph, January 23 through April, 5, 6, and 7. And if it's increasing, so let's jot down some info here. There's a bad mark right there. Let's go. Pardon me, I jotted down some incorrect dots, but we're going to use that as a reference. So it's going to be let's say 6.2. So in January, we're starting at 5. Then we our slope is moving upwards towards 5.5. Then we have here at 6.2, so that's a 0.5 increase, that's a 0.7 increase, and here we're at 7. So this is a concave upward slope, or a concave upward graph with a slope that is increasing gradually, but still increasing. So yeah, and that's what that graph would look like. Okay, now for task 2, we are asked to observe the graph given here. Part 2, sorry about that. Sorry. Now for task 2, we are asked to observe the graph given here. The slopes of the tangent lines here give the derivative of the function at that specific point. As the production increases, the slope of the tangent line decreases. So here, as production increases, the slope is decreasing. Here we have almost like a 90-degree slope, and then here we have a dramatic decrease towards a 45-degree slope or something along those lines. The total cost function graph concaves downward. So as production increases, the production process actually becomes less efficient. And yeah, essentially that's all we got for that, for test 2. I'd like to end by saying I'm also currently studying microeconomics. I'd say this course has helped me tremendously to understand the logical concepts of business. Microeconomics is the study of how business and people make decisions using limited resources. I would state that cost functions and marginal analysis have helped me to understand microeconomics fluently because I can calculate strategies for proper economics equations. That'll be all. Thank you for your time.